Oh boy. And we are live. Whew. Just coming from the outside. Crazy outside. If you want to see, let's see if we can turn this around. Yep. That's how it's outside right now. It's -12. Snowing, windy, and the dog said, no, thank you. And I agree. Oh boy. All right. We're going to be continuing with network policies because it didn't go so well last time. That's a good segue to a rant, I suppose. Software development is a social activity. It's a social engagement. And let me turn off all these phones here. And it's not an individual effort. As writing memoirs or a book, something like that, right? So it takes a community to write software. That means that when you write software, you're going to make mistakes, and people will see those mistakes, and they will judge you. And the whole idiom, why are you judging me? It doesn't make sense. It's stupid, right? Because also it doesn't apply to engineering. We write code. We show that code to our coworkers, maybe to the public, and they're judges for it. And it's okay. You have to be okay with people judging your code, and expose your mistakes to the world, and let them see the mistakes. And well, let's talk about mistakes, actually. So, jumping straight into network policies and Bitnami Helm charts, and this is their official chart, and there's a bit of an issue here, and that's what caused some of our headaches yesterday. And I'm going to unpack this and show you how to test it. And we do have, where's my system here? We do have it up and running right now with all the network policies, the way they should be production ready. And we have to tweak them a bit and also adjust the policies for observability as well. That's the last thing we have to do. But getting back to the issues, so here's one of the issues that I didn't consider yesterday. And those mistakes are actually not part of the source control, so I can look at the mistakes, or whoever's going to look at my code. So here's the problem. So when you enable network policies for Postgres in a Bitnami Helm chart, and this is it's a common way of doing it, you are enabling a port, right? So there's a standard port that you access the database on, and it's going to be part of your ingress policy here. Now, things get complicated when you start using TLS. So when using TLS, there's additional ephemeral ports, I'm going to call them ephemeral, that are created, used to establish a TLS communication. So while this network policy is fine for just your vanilla deployment without TLS, now you should always use TLS. Again, zero trust applies. You should not be having plain text communication even within your cluster on your privileged private network. It just doesn't make sense. So you should always enable TLS. Okay. So once you enable TLS, then you're going to have these issues. Now, I'll show you how to test these issues or how to prove it to yourself. Because one thing that comes from engineering point of view, you always ask the question why, and you need to find the answers why things are happening. Nothing happens by accident, right? The software has to work a very specific way, And if it goes outside of that standard, you ask questions and you try to figure out what's happening, right? So let's verify to ourselves that my claim that this Helm chart is broken for TLS communication, because it doesn't, there should be some sort of if statement here to change this this policy a bit for networking, okay? So let's do that first, and then we'll go back, and I'm not going to change the bitnami chart. What we're going to do is probably disable network policy in the Helm chart, and we'll add our own network policy with Helm post render. This just gives us the ability to kind of patch the system. And we might open up pull request to bitnami a little bit later and engage in open source. So let's have a... All right, anyways, let's just first prove it to ourselves that this is the issue. Although the network policies are running without it, and they're fine. So, but that's not proof. That's just mine. It works on my laptop type of excuse, right? So let's just grab the. Well, let's look at the backend first. So, yeah. So. Looking at the logs from Langflow backend, we can see that that they hate DevOps people, because who does logs like this, right? Who puts them in a column like that? I don't even know why would you do it that way. Anyways, so yeah. All right. Anyways, so let's clear this. Let's have a look at all the network policies that they actually have that are running right now. So we have 3 of them. They're applied to those 2 different digital assets that we have. Let's have a peek at the backend one quickly, just to show you how it looks. And so let's make this a little bit bigger. All right. So you can see we have egress and ingress one. So the ingress is obviously the simpler one. So this is just to allow the front end to talk to the back end, and it has this match label, and we just open up the ports, right? These are the ports the server runs on, right? So if I scroll back up, well, I can't right now. Yeah, you can see the server starts on this port. Now for egress, right? This is where things are a little bit more interesting. So in here, we need the DNS for the name resolution within the cluster. We also added this bit here to allow other to talk to other containers or pods within the same namespace that would deploy part of the Helm chart. Now, this is where we had issue yesterday, these 2 conditions. So the first one is a Linkerd. So Linkerd uses a lot of different ports to talk to the mothership, to the control plane. And we are running in a special namespace, Kubernetes security. So we protect this specific namespace with our lives. And that's where the Linkerd control plane is running. So we need to kind of give it access as well. So we don't have to go port by port. We can just give access to kind of everything that has a specific label. There's many different pods that are included in Linkerd in the control plane. So, defining everything port by port doesn't make sense. So this is a better option. So we need this for Linkerd for the service mesh. Now this is unique to my deployment here, or our deployment here at Kubernetes, because we use a service mesh. So we need to allow the site container to talk to the control plane and do its thing, right? And the last thing here is we need to talk to the database. Now, in this case, we're not defining ports. We're just saying just talk to the the pod itself, right? Because there could be many ports as well. Okay, and the same thing happens on the front end. It's very similar. So it's a little bit simpler. Again, port 8080. This is for the ingress for the traffic, inbound traffic from the to the React application, and then we have again the Linkerd and then DNS. So this one's very simple. Okay, it just request comes in and that's it, and it just leaves and goes on to the backend. Okay. Now for the Postgres, this is where the issue is. Postgres Langflow. So as you can see, I already removed the ingress here, the ports here. That's why it's running. So we're just basically using this selector, which the label we have on our stateful set, to talk to this to the database, right? If I add the ports back in here, it's just going to crash, and I'll show you why it will crash. So let's show you how I tested this, how I proved this to myself. So I'll prove it to you as well. I have I have a command in here, run command. Now in this case, I'm not using my standard client. I'm just going to go straight to Ubuntu because I want to install Postgres and a couple other tools here. So then we can establish a connection to database and use tcdump to look at the ports and what's happening there. Okay, and also one important thing here is I'm disabling the service mesh here. So I just want the container to be deployed in the same namespace, but I don't want the linkerd service mesh to be injected into it. So I'm just disabling it, right? And also I'm adding to this run command volume. This is where the TLS is, so we can make a TLS communication. So we can establish TLS from our test container or test deployment, and then see if we can mimic how the backend should be communicating with the database. Okay, so this is the command. If anybody wants to, I'll post it. It's fairly straightforward. Just run in the namespace using Ubuntu. Here, Ubuntu image, and we're just overriding it and disabling the linkerd and adding volume mounts and volume for the certificate. Okay, so let's just grab this here and just run this in our terminal. There we go. So we're in. Now, if you go back to the dashboard, let's refresh this. We can see that we have Ubuntu test running here, right? So it's in the same namespace. And now we can pretend to be the backend and talk to the database and see what's happening there. Okay. All right, sweet. So first thing we want to do is install pSQL client, and let me just grab it, and tcdump. So I'm just going to grab my command here. So where is it? Go back. Let's clear this. So just installing Postgres client and tcdump so we can actually test this. Okay. So now we have the both of them installed. What we can do is we can run the tcdump in the background to capture the traffic, and we can then in the foreground run the pSQL command. So let's run the TCP command in the background. So we're just going to be listening to the database on that specific port. Just run this in the background. And now let me just grab my pSQL string here. There we go. There's the password. Again, it's okay for me to expose it because it gets rotated automatically every few hours. So it's not like somebody can go and log in. There we go. So I'm executing it here. And at the same time, I'm capturing the TC traffic here, TCP traffic. And you can see this is TLS here as well. Yeah. So while this is running, you can see the the destination and the source. We can look at the log at the same time of Postgres here. Now it's not going to connect right now because we added one more condition there. So, but let's get the log on the screen just regardless, and let's adjust our labels as well. So it's trying to connect right now, and you can see these different ports here. These ephemeral, I'm calling them ephemeral ports here, which are also have to be exposed in your network policy. It's not just the standard port. So let's go back and adjust our output here a bit. Just exit here. So one thing that we did is we also go away. We also added look at the policies, back at the policies. Where's the policy? Network policy here. Not this one. I want the Postgres one. Postgres. So we need to add this label to our test container here. So let's just do that. So I'm just going to add it to the labels here. No, labels. Come on, cursor, help me with the labels. Okay. Sweet. All right. So we just require that label. So any pod. So let's just delete the. Let's go back here. We have an Ubuntu test, right? Still running. There you go. Just gone. We just killed it. Okay. So now we'll just run this command again. Again, with disabling linkerd, we're adding a label on the labels, just so we can, make this network policy happy here. That should make it happy. Oh, crap. Wrong one. Make this a little bit bigger again. All right, clear. All right, so same idea. Let's just install psql client here and TCP dump. So where's my commands here? So we can quickly get going here. All right, let's kick off TCP dump first. Where's my command? Well, I saved it. Where's my command? There you go. Let's capture traffic and just put this in the background as a background process. And now let's just grab the psql command with the password and TLS as well. And there we go. Right. So that was a little bit faster. So you can see it connecting. And look at these different ports in here. So we have the traditional port here, 5432, but we also have the additional ports here. So if you go back now to the logs, logs. Right, so you can see the connections here, right? You can see these ports here. So put them side by side so you can see it. Okay. All right. So there you go. So this kind of gives you an idea of what's happening when you actually make the connection to the database. You can see we're in the database right now. We can start looking at the tables. What's the Postgres command for tables? /dt or something? /dt. There you go. So yeah, so we're in a database. So we use the client to connect the database to the network policy, and we can see that when it's connecting, it's just not just that specific port, right? So yeah, so let's now go back and adjust the Bitnami Postgres chart, and yeah. Now we can prove it to ourselves first if we can still connect to, let's exit this. So if you go and edit the Bitnami chart, the network policy that comes from Bitnami chart, let's edit this here. So what they have on the ingress is And just copy from their chart specifically. So they have ports and port, right? All right, so we'll just add this here. And the port is 5432, right? There we go. So if I add this port right now, just make sure the tabs are okay. All right, so that's the port, right? So the only thing we changed, we just added a port, right? So let's just do two things, right? Let's see what happens to our application right now. So if the backend still can connect to it. So if I go and kill this pod right now, it's happy, it's running. We just change a policy just out of the port. We just allowed the ingress port to be 5432, the standard Postgres port. We're just doing this just to prove it to ourselves that there's Helm chart issues, there are network policy issues in a Bitnami Helm chart. And let's see what happens here. Let's look at the logs in the terminal. So we may make fun of Langflow DevOps just for fun. Let's just cause some drama. Drama, mama. Too much K-pop. Shh. All right. You gotta love these. Anyway, so you can see the database is you can't connect it, right? So right away we get this. And again, who puts logs in this freaking column like that? I don't know, which is weird. Anyways, so you can see that there you go. It's crashing right now, right? And the only thing we did is we just updated the policy, the standard policy that comes with the Helm chart, Postgres, Bitnami Helm chart. Just get this, and we just added these ports. Okay, that's all we did. Yeah. So there you go. So I think that proves that there's your evidence that when you enable TLS, you have to allow more ports, right? Also, let's do this with our Ubuntu test client. Let's see if it's still running. Delete it. It's gone. Cool. Let's just grab this Ubuntu test client that we have. And let's install Postgres client again and TCP dump. So you can see what happens when we try to connect. Where's my TCP dump command? Here you go. So let's listen to the ports again. And you know what? I'm just going to listen to everything right now. So I'm going to remove let's just listen to everything, not just specific. Okay, so here you go. So there you go. TCP is dump is enable. Let's connect to the database again with that network policy that I'm saying is incorrect, which is definitely incorrect, but just prove it to ourselves. There you go. Here's the, again, database connection string with certificate here with TLS. See what happens. Oh, snap. Look at it. Look at that. All right. I'll just kill everything and let's see if we can massage the network policy for the Bitnami Helm chart. And try to massage it. Yeah, let's do it like that. Let's just exit everything. Exit. And let's make the deployment happy. So let's just go and edit the network policy again. And the only thing we're going to remove is, oh, bloody hell, where's my edit? Just type in edit. And let's just remove the port section here. The rest can stay the same. And let's see what happens to our pod now, see if it's going to be happy or not. Let's delete this. pod not stateful set. In the meantime, we did ask Coder yesterday, or Cloud Coder, to start recoding the Langflow React application and Python. Let's continue. They require more credits. Can you continue? Nice. We ran out of credits yesterday. Anyways, let it do its magic, and we'll come back and take it over. It's doing its thing. You go, Claude. Go. You go, boy. All right. So let's have a final peek at our stateful set here. Let's look at the logs, see if as you can see, it's connecting, so it's going to be up and running in a minute. There we go, server's up and running, right? So just that one simple policy there that setting the ingress port messed us up. Okay, so let's see how we're going to fix this. So let's just go back and make sure everything is fine. Everything is green. Yeah, it's all green. Okay, so everything is running. We have network policies. They're secure. They control the traffic. Front end can only talk to the back end. The back end talks to the database, right? So, we control the access, the flow of traffic between these pods, and only the back end has access to the database, right? So even if you get past, get into the React application, the front end, you're going to have difficulty getting at the database because you will have to go to the backend, right? So you have to kind of, so it makes it a lot more difficult for you to extract the database. You have to kind of get into the backend container or the Postgres container, find a way in there, which is more difficult. And it's very difficult to get through the front end to the database, right? That's blocked. Okay. So that's what I mean by production ready. So this is production ready right now. Now, what is left of, what we have to fix right now is the Bitnami port that's added on the ingress. And also we need to enable pod monitor port to be able to scrape the backend metrics. Because right now, they're not being scraped. And we're not going to enable the metrics on Postgres. The reason is that, well, let's talk about Postgres in general. So if we go back to Bitnami chart, they also have here enable metrics, and they add the metrics port here. We don't enable that for a simple reason that it forces us to expose the password within this Helm chart, right? So the way they designed the Helm chart, I don't think they were thinking about production issues because being able to run the metrics side container, because it's done with the side container, you need to give it you need to create a credentials for it, and those credentials live in values YAML. So instead of that, we just use a separate Helm chart Postgres extractor to extract the data, metrics data from the Postgres database, and we manage credentials through Vault, right? So I would urge people not to enable the metrics here. So if you look at where's the metrics section here? Here, metrics. So you can enable it here, and it will just kick off this Postgres exporter for you. But obviously, this container needs credentials to the database, needs database credentials, right? Well, you have to manage those credentials here, right? So then you're going to have a little bit difficult time to manage the credentials here. You can definitely still do it with Vault. You can inject at runtime. It just becomes much more difficult, right? So in this case, we separate the deployment of the database and the deployment of the metrics or the collector that collects the metrics from the database into two separate deployments, and then we can manage the credentials separately, right? Again, security makes things more difficult. So Yeah, so don't enable it here. They still haven't addressed some of these issues in this Helm chart. So I would say disable it and then run the, create another chart with the Postgres exporter outside this Helm chart, so you can actually manage things, the credentials of the accounts, the database credentials correctly and securely. Well, correctly is subjective. Securely, let's put it this way, securely, because right now it's not going to be secure, right? So, in fact, I can show you here. If you look at the metrics, that would be not the service monitor. It would also be on the main one. Where's the main stateful set? Where's the metrics here? Here, metrics enable. So you can see they added as a side container to the to the stateful set beside the database container. So where is the command to actually run this? There's the command, and right. So here's the database password file, all that stuff. So yeah, you want to avoid managing it here. So while this is it's nice to have it in one deployment. So you have a side container that just gets deployed with your database container, and then it collects the data for you. It just becomes cumbersome for production reasons to kind of to deal with the security issues here, how it's designed. Also, you're packaging the metrics container with the your main container, and then the computation resource issue becomes also a problem. So so you want to, every time your database goes down, you still want your monitoring system up and running. So when you do making change to database, you still want to have the observability on it, right? So separating those two things, there's two separate concerns, right? So packaging it, while convenient, it just creates issues, production issues, right? So stay away from it if possible. I'm suggesting strongly to stay away from it. Anyways, moving on. So we do have this one wrinkle here where we need to be able to deal with this port if you're going to use this Helm chart and enable the network policy, right? So in this specific chart, there's no way for us to change this because it's hard-coded. So they don't give me an option like this one here where you can add extra egress or extra ingress. This is just set here by default, and that causes us problems. That's just one line here, okay? So I'm going to basically disable the network policy for the database for now and see if I can submit a change request here to put an if statement here, just so we can just have a same thing as enable metrics here. We can just have an if statement here, right, for to use this port like that if you want to, right? So I can maybe even do it based on TLS, right? And so something like that, or TLS enable, whatever, something like that. So I can figure out later when I'm doing it, but this will give me an option to enable, disable it, and it gives me more customization in this chart, right? All right, anyways, remove this. So since the only way I can do this is to create a post renderer hook, I'll use the post renderer in Helm release Terraform provider to deal with this. Let's do it. Why not? I mean, let's just do it. Okay. So what we're going to do is, first of all, let's do it 2 steps. So let's create a Git process first. Let's create a branch to disable Postgres network policy. Right. Let's create our dev branch, and we're just gonna go to the values YAML and disable it here. Where's my values YAML here? So network policy here. Right. So I'm just gonna say false, disable this, and I'm gonna just delete all this. So that's the first step. Okay, let's push this change to Atlantis. Let the changes be applied. Commit, turning off NP for Postgres. Okay. There we go. Let's just go create a pull request now. So Atlantis can kick this off. Delete the branch. Looks good. Just simple. No spelling mistakes. I'm notorious for spelling mistakes. No, false. Okay. All right. Atlantis plan. Atlantis apply. The usual GitOps process applies. Helm. Okay. All right, so plan has finished. Let's do apply. Yeah, make sure you remove formatting. Atlantis is not happy with formatting. Okay, let's see. It should be done. So it's just a network policy. It should delete it, reconcile the state, and delete the network policy. Everything else should be the same. So I'm expect to be finished like in a second here. My hands are still cold, man. Jeez, it's freezing outside. Shoveling in this weather is not. Anyways, merge, but okay, we're good. Okay, so let's just have a look at. Yeah, nothing should change here. This all should be running, and let's just clean up as always after Git process. You want to make sure you clean up your local branch. All right, delete it. Yeah. All right. So now let's just create a new branch. This is for post renderer on the Helm provider from Terraform. So let's just go Postgres custom NP. Let's just our custom NP. And let's just verify if we have the only 2 network policies right now. If the Postgres one was deleted. There we go. So that worked. Okay, so what we can do here is in Postgres Helm release here, we can use this new feature, which is the Helm post renderer or post, is it called post? Yeah, post renderer. And we can define a script that will execute right after the Helm release. And in this script, we can add our network policy, which I wish I did not delete because, hold on, damn it. We'll just have to come up with our own version of it. Did I save it somewhere? No, I was going to, crap. We'll just write it out. All right, so first thing we have to do is update main. So in main, we are going to do what? So we need to create a script first, and then let's look at the Helm release. So then we call the actual block, the Terraform block, Terraform Helm provider. Let's have a look at that. Let's look at not the latest version. Okay, so we need to have the post renderer, which is it's alphabetical here. Post renderer. It has nested scheme. Okay, so it needs to have binary and arguments. Okay, so binary path is where the file exists, and arguments, we can pass in arguments into our script. All right, let's do this. So binary path is the first thing, and that's going to be where the script is. Let's just add a script here. So it's going to be under the root, also in infra. Let's put it in infra. So this is going to be in the Terraform root directory. So np fix sh. So we're going to put, oh, we should probably put a path here. What's the path? What's the variable path for Terraform? Gbis, I always forget. Where is it? Move out of the way. Where is the path variable? We could just use the local file resource. Yeah, let's use local file. So I don't have to create. Yeah, you know what? Let's forget this file. So let's use a local file. Yeah, it's going to be easier since we can just create it dynamically within our Terraform code. So resource, local file. You know what? Let's just go back to my Terraform here. Let's look at the local file doc. Local file. This one here. Okay, so it's a standard resources come with Terraform by default. So we can define the content, the file name here, and then we can pass that on to our post renderer, which might be nice because then we can have some dynamic parts in the network policy. All right, let's do that. Sensitive file? No, it's not sensitive. Yeah, it's just network policy. Okay, so let me put this to the side so I don't forget my docs here. So we have local file, we have content, and we have file name. Okay, so let's call this network policy. Oh, let's see. Renderer. That's renderer. All right, so that one is we need the file name and content. So file name is going to be one thing, and then next thing is content. Okay, and for the content, let's the file name first. So we'll put in the path of the module root. No, module root. We're going to put it. You know what, cursor? I'll agree with you. Let's just do that. Okay. No, I don't want to put on the script. So just put it in the. Okay. So just call it network policy renderer sh, and now here for the content. It says here the content is going to do what? Just going to double check here. File content must be specified with exactly one of the arguments, contents of content. Okay, so we just need to put in content, and the content is UTF-8 encoded string. What's in the file? So since the post renderer executes, this has to be a bash file, right? So let's make this a bash file. So let's just do, let's just write a bash here file. So let's do dash EOT, and close it into EOT tags. And now we can add our bash file here. So let's add our shebang first. No cursor, no. Follow me here, cursor. Bin bash. Yeah, we do have a bash on Atlantis. Yeah, it's not sh, is it? No, I did install bash. Okay, it's bash. Next thing. All right, let's grab the network policy, the one we want to put in here. And I wish I saved that previous version. I'm very upset that I didn't, so I can just copy paste that here. But let's just get the Bitnami one and remove the template stuff. So I want this with some changes. Let's just go up to, I want this, just like that. All right, so just dump this here. I'll just fix it up. Crap. And we're going to dynamically add these variables here. Full name. First of all, let's add the API version here. Now, so this is where we have a bit of an issue here. We're going to make an assumption here that you have the latest cluster. I'm not going to have an if statement here for kind of capabilities. I'm just going to grab one of the network policies here and just use it as we have in our cluster. So the issue here is that the API version changes with, it went through transitions, obviously, right? So it changed, it's a full version right now in the latest cluster, or since like 1.23 Kubernetes or something like that. And so before it was a different version. And this is what the Bitnami chart gives you here. And they do this if statement for you internally. So if you look at the chart, and they use a child chart, which is their comment chart. So if you go, and the comment chart is a library chart, it's not a regular chart. So if you look at this chart here, it's of type, where is it? Type of library, right? So it's just specifically used to be added to the other charts, and they could put all the common stuff in here. So for capabilities here, if you look at they deal with different versions here, templates here. So 1.7. Okay, so it went from beta to 1, right? So I think we're okay with not adding this specific if statement there. There's just no value because 1.7 is really, really old here. Okay, based on this version. All right, moving on. All right, so that's fine. Name, full name. Right. Did we do a name override somewhere in this chart? Full name override. There we go. So we're just going to use this full name override. That's going to be our name. And because this is still HCL, we can actually add these things dynamically here. So let's do that. Okay, so that should be okay. Next thing, namespace. Namespace is going to come from our namespace here as well. This namespace, local namespace. Just double checking stuff here. Yeah, we're good. Labels. I'm going to steal the labels from the pod. Where's my labels here? Labels. Just to be consistent. So we have consistent label. I'm not going to put the Helm chart version. So this is the standard labels that are added by the Helm chart. And in our specific case, we don't need to do that. Especially if you're going to change the chart version. So I'm just going to remove this Kubernetes version, this. I'm just going to leave. Yeah, that's how I'm going to leave like this. Okay. For the annotations, there's no need for annotations in this specific network policy. Right, you can see we rarely add annotations on these ones here. Well, rarely. Well, you have these ones here for the release, Helm release. So we don't need annotations here. All right, spec. All right, so here we are going to clean this up a bit. Pod selector, yes. We'll match this based on, again, the labels that we have in the pod. So pod labels. I'm getting stateful labels. Let me get the pod labels. Where's the pod labels here? So we just use these three. There we go. We have one of them already. All right. So we're going to have both ingress and egress policies. Not allow all. So this one here, allow DNS resolution, yes. Up, yes. Port. This is where we don't do much with that. We'll just I'm going to delete all this stuff here because we don't have any replicas. We just have one pod in a stateful set deployment. There we go. Now for ingress, we're going to, again, remove the ports. So I'm not happy with the ports. So that's gone. I do want to leave this section in here so we can tell about the different pods. So, and like so, just this. And the full name, again, comes from service name. There we go. Now, I do also want to add linkerd just in case. So I'm just going to grab my linkerd from here, from this values YAML. So to egress, again, since linkerd is also added to Postgres as well, it's injected. And we are going to add it here. Okay, there we go. So this is the network policy that we want. Now let's make this into a bash script. So what I'm going to do, I'm going to put this in a temporary directory, and then cut this let's do that. Okay. So right now this is just a string. We're dealing with files here. So we're going to squeeze that string into a temporary file, and then the temporary file will be dumped into this file, which then goes into the renderer. Okay, so let's do that. I should probably put some comments here. So let's read this. I'm going to say, let me write the command first and then figure out. So let's cut this to ampersand. Let's go 0. Yeah, let's do that. And should we put this to temp? So Atlantis, yeah, we did map temp on Atlantis, so temp is fine. And then we just put this in manifest. Let's just give a better name. Temp np, well, Postgres, SQL np manifest dot YAML. Okay, so this is going to be our YAML now. After that, let's dump the whole thing into another file. And yeah, so I'm just going to go cut this and cat. Let's do EOF and let's put this into temp. I'm gonna give it a better name as well, just in case we have to go debug it. So temp. Let me see the dog for the provider. Right. Okay. So for the binary path at the end, we need to get we'll get the local file. Just this local underscore file and network renderer. And in this case, we just need to get the file name, right? So that's the output, the file name. So let's go work backwards. So this will be executing the bash script. So working backwards, the file name here is this, and the content is this. So let's add depends on as well, just in case. So that has to depends on local file. Okay. So just try and create some dependencies here between the different resources. So we want to wait for the bash to execute, and then here. Okay, cool. Now let's get back here. I do want this to be yeah, let's just put this in network policy, network, okay, spell network policy YAML. Okay, so if I squeeze it in here, so that's good. And then let's just end the EOF here before the EOT. Okay, so now we're going to have this manifest here in this file. Now we need to execute this. How are we going to execute this? You know, we should do a kubectl command in the bash script, right? So then, because we have kubectl installed and it has all the right credentials, so we can just grab this file here and just use it with kubectl apply. Why not, right? That would be the best way to do it. Yeah, if that's the case, then I don't need to do this. I can just directly pop it into kubectl apply. Oh, let me just double check what is it executing the file or not? Because we don't do the renderer often, so I don't remember right now. Where's the renderer? Let's just look at the doc because I just don't recall right now. Let's go back to Helm. Let's look at the documentation. Post render command configuration. Okay. So this just executes the command. Okay. So we can runs the command, and we can just pass an argument. So the command could be just a simple kubectl command apply with network policy they already have. So why not make it as simple as that? Hold on, let me see the messages here. Yeah, let's do that. Why not? We don't have to complicate that bash script. It's just actually we did one already. Let me go back to my repo. When we fixed the original Langflow chart, it had issues, and Yeah, let's look at the history here. What I did do here. In this case, we did the patch ingress here, and we just passed in the ingress class name as an argument. Okay, so kind of worked around that. Now, at the same time, what's in the patch? In the patch, I had. Oh, that's not correct. This must be an older version. Oh, what? No, that's not the right version. Where's the history for this thing? Why? Full commit? What? Let's look at the commits here. This thing's being difficult. Yeah, that was a couple days ago. Here, yeah, I'm here. So let me look at this here. So what I do in this one here. Right. So in here we just found right in this YAML. Okay. So I guess we can do the same thing here. Yeah. Okay. All right. So not kubectl apply, but we're just going to dump the YAML out of the post renderer. Okay. So going back here, actually, let's put this on the side so I have it as reference. Let's adjust the post renderer here then. So the goal here is to dump out the file here. So does that make sense? I just need to. What would be the best option here? So hold on. I'm not doing this correctly. So first of all, I'm going to read in the manifest here. So let's do that. So I'm going to grab the read in the standard in Helm renderer manifest. If I can spell manifest. Manifest, okay. And then here, let's say what I'm going to do, create new network policy. Network policy, so people know what I'm doing here, policy, sweet. And then once I have those two things, now I'm going to combine them here at the end. Let's combine them and then spit out the final result. So I'm going to combine. Come on, cursor, type for me, damn it. What are we paying for cursor? Combine the manifests. Sweet. Okay, so here I'm just going to do oh, thank you, cursor. All right. I'm just going to cut these two things, but I'm not dumping it. I'm just doing like that. Okay. Yeah, that makes sense. They call it for policy. Yeah. Okay. All right, sweet. So I think we're good. Yeah, looks a bit confusing because it is, but I think we're okay. Do I need to set file permissions here? Where's the thing here for local file? File permissions. Default is 077. Okay. All right, so we don't have to set the permissions. So to make it executable, we have to make it 0755, right? So that's fine. That default permission is okay. All right, let's run this. Let's see how badly you messed up. See, there's any spelling mistakes here? No, good. All right. Well, the plan stage will tell us if we messed up, right? So before apply, if this resource is incorrect, just want to make sure we have the right name here, namespace. We are attaching to the specific pod, which is the database pod, and we're allowing service mesh DNS as well, and then we just have a selector here, which just requires for you to have this special label in your pod. So okay, so I think we're good. Okay, let's see what Atlantis thinks of these changes. Renderer. Renderer. Okay. So we should get some feedback from the plan stage of the syntax issues. And I think I made some boo-boos there with syntax. Where is my window? So we can do a pull request. Pull request. Delete the branch. All right, looks okay. I mean, maybe some of these tabs here. Maybe I should probably have comments here as well. This is for linkerd. This is for, yeah, it's always nice to have comments. Binary, what? Why is it empty? What? Didn't I just say? I did not, what? All right, hold on. Yeah, that's one of my pet peeves with cursor. I always forget to set the properties to do autosave. I usually copy my VS Code hidden directory there with my properties there, and I always forget to do with cursor. Typos. All right. Push. Okay, so let's see if there's any more boo-boos here. Let's just do a pull request again. Pull request. Delete the branch. We always have to clean up the branches. Oh yeah, that looks a bit better now. This depends on network policy renderer here. Goes to path module. I think path root. Okay, path module, fine. The EOT is here, and this ends on the same line. The EOF is good as well, EOF. And reading into the file here is good. Okay. All right, let's see what Atlantis tells me about the syntax here. Once it checks the syntax. Oh, let's have a peek at the Cloud Coder that's redoing. Oh, look at that. Look at that. Cloud Coder, you the champ. Let me see. Oh, look at this nice feedback here. So I asked it to start coding or updating the project to add Keycloak authentication or SSO, single sign-on, using Keycloak, and asked it to update the Python backend and the React frontend, at least to get it going. And it did that. and install dependency. Okay. Sweet. Okay. Key code callback. All right, I don't have to code that React component. Okay. Let's have a look at the code quality. All right. So the goal is here to remove the login page. So where's my? Let's go back. Tell you what I mean by that. So when you configure Langflow when you deploy it, we deploy it right now, is you get this login page right now. Okay. Which means you have to manage users within Langflow in their database, right? Now, we don't want to manage users in multiple applications, right? We don't have a single sign-on, especially for enterprises or small businesses. You want to manage users in a centralized place. You want to centralize the user management, both the authentication, authorization, both of these things, right? So we don't want to have this login page here. In fact, we want to have what we did for Grafana. As you can see here, there's a Grafana login, and we can just click on single sign-on here with Kubert, and then it just goes to our key cloak and gives you ability to type in username and password, or use or proxy to Google, for example, and then just log in, right? So we're doing this for all the other systems as well. We have a single sign-on. We don't use Clerk. We deploy on authentication, SSO provider. Sorry, Theo. Theo is a big huckster for Clerk, the sponsors channel. So a lot of front-end developers don't deploy their own single sign-ons, which is fine. I mean, if not the skills, so don't do it. Now, we do it because, again, we run the whole infrastructure, the whole pods, and we'll provide all the tools. Also, when the agentic AI is deployed, we also wanted to have its own authentication authorization process as well. And having Keycloak there makes it easier, so you don't have to go outside to Clerk. So Clerk is an amazing product. It's geared towards front-end developers, which are really focused on the business application. Use Vercel, dump your React application there, minimal backend, and you just wire that to Clerk, and you have it. In our case, we deployed the full shebang, the full platform, Keycloak and everything. So, and then we can just wire that to all the different, digital assets that we have, assets. Anyways, moving on. Let's see what Bitbucket said about my script here. It seems to not complain about the syntax too much, which is nice. So let's apply it. Let's see if it chokes. So this also should be fairly quick since it just applies to network policy. So there should be no refresh. The pods should not be refreshed. We're not touching the pods, anything like that. We're just changing network policy. What happened? Yeah, okay. What I messed up. Line 297, right? Did not find expected key YAML. Let's see if you can look at the output from Atlantis here. Let's see if it opens for me here. So this was number 15. Number 15? Wow, okay. Where's number 15? Here. Well, wonderful. There's no logs here. It crashed without logs. No, damn it. What about the plan pre-stage? No. Oh, that's disappointing, Atlantis. Where's my logs? Where is my logs? I'm gonna have to have a chat with the Atlantis people that deploy Atlantis. It would be nice to look at the logs to see where the problem is. Let me see if this one, if there's logs here. No. All right. What we can do is also inspect the Helm release and see if there's logs there. Go with Cloud for now. I just want to see where is the actual mistake. Where's the boo-boo that I made? To get some quick feedback here. List and just Oh, N, sure. N for N for namespace is always not N. Oh, all right. We need to log in to a Google account. As always, it's a bit painful, but security is security. All right, so we have the two charts here. Right, so it didn't get a chance to do anything because it crashed before it started being deployed. Okay, so we don't even have, do we even have the releases here? So this one was deployed. Hold on, what's the command? I want to look at the status, right? So status, and I think I need to give the name of the chart, right? Right, status. Oh boy, all right. So yeah. All right, let's see if we can look at the code and see where is the mistake. We can always log into Atlantis and have a look at that output there. Maybe that's what I should do to save some time. Oh, hold on. Hold on. This should be a dollar sign here. What am I doing? What, Jeebus. Low in sugar. Low in sugar. No, that's my excuse. Okay. So that's the way that should be. Okay, cool. All right. Let's push this. You dead to me, Atlantis. Go away. All right. Let's apply these changes now. Well, we should get quick feedback if there's a syntax error right away. It's very efficient when it tells you how wrong you are. Oh, it did work. Oh my god. Okay, let's before we clean up this branch, let's have a look at network policies. All right, so there we go. So I added the one with the post renderer. Let's see how it looks before we delete some of these pods and see if there's a connection issue. Looks okay. Yeah. All right. Yeah, let's clean up. Again, checkout master. I'll check out main. We got BPC. No more masters. Just main. Don't cancel me because I said master. Delete. All right, so we're back in trunk. Let's go to trunk from now on. So let's do a quick test. If everything is fine, we can delete the oh, well, that's interesting. Wasn't expecting that to happen. Postgres is gone. All right, so that obviously that YAML was crap. Oh boy. All right, let's have a look what happened here. Where is my stateful set? Hey, let's see where we made a mistake. And so what we can do is we can grab the values from this Helm chart. So what we can do is get manifest. I think it's manifest, right? And give the name of the chart. Sweet. So what did we mess up here? So network policy is good, so that's not a problem. The stateful set is good. There's no problems. And what else? Did we mess up anything? No, it looks all good. That's a bit strange that it deleted the stateful set. There's nothing wrong with this. In this manifest, it's all good. Oh, that's interesting. Bit unusual for the Helm chart to delete the stateful set just because network policy was like, oh, but look at this. Oh, I see. Look at this. It's missing the separation between the YAMLs. Damn it. See, it's missing this separation between YAMLs. Okay. So the post render worked a little bit too well. Let's add this here. All right. Let's, damn it. I thought it was so beautiful. It was tremendous. Best ever. Tremendous. Beautiful. And let's just do another branch. Postgres fix. And there we go. People can see all the mistakes that are still alive here, okay? So you need to be okay with being judged. Judge Judy's here for you. She's helping you. All right, pull request. I am happy that the network policy worked first time. Yeah, and it looks pretty good. That's the one we wanted, or at least that's the one I wanted to have here, based on these network policies to control access. So yeah, we only have, anybody that wants to access needs to have this label. And we allow linker D and DNS. So it's all good stuff here. So it's good. All right, let's apply this. So we should see resurrection of our stateful set pod. Postgres database should come back to life. Come on, where's my Postgres database? Come on. Oh, it just finished. Well, let's have a look at this. I wasn't expecting there to be more issues here. All right, so it did deploy. You can see the revision here. Let's look at the manifest for the new revision. What? Where is my? Why is this not there? What? What the bloody hell? How is that? Well, that's strange. I wanted my little doohickey to be there. Is it because of the merge here? No. What? Well, I was expecting this to be there. What the bloody hell happened here? Hmm. Well, that's a problem. Okay. There's no separation between the manifests here. So yeah. So this is a problem here. So you know what? I'm just gonna add it right here. Okay. Because that is just unacceptable. uh, yeah. Right. We're almost there. Almost there, minor. I'm gonna call this a minor fix. Okay. Extremely minor. Let's move this to the side. All right, now, and it's a bit silly that this string was not respected because I don't see it here. So I think it used, you know what, let me delete this temporary files just in case, because I think, just to be sure, make sure it's rerunnable, I don't want to be using old temp files. So yeah, let's, yeah, no, this should work. So I'm assuming you just use a temp file. I didn't, let's clean up. So before we start here, let's clean up the temp files. Actually, hold on. It's not just temp files. The local file needs to detect changes, and those changes then, because there has to be meaningful change in the state, otherwise it won't trigger the update. Yeah. Yeah. Anyways, let's clean up. Let's just assume that it's a temp file here. So I'm just gonna just clean up temp files. Okay. Let's make this first thing. So let's remove both of these files. Yeah. Thank you, cursor. Nice. All right. Yeah. Let's do that. Let's make an assumption that this is just a temp file issue. We should probably clean up after we complete it as well. No, we'll just do it here. Okay. All right, let's push this. Where's my Bitbucket full pull request. Oh, snap. Yeah. Hold on. What did I just do? Check out main. I did not follow my own process, did I? I did not. Okay, so let's just sync. Let's merge main into the. Let's check this out. Check out. And merge back the master. Sorry, main trunk. Merge main. Main? Did I call it main? Main, yeah, not master. All right. This also should complain here. Create a new pull request. Yeah, sync. All right. Sweet. The plan is having a problem now. Right. The cleanup. It's not liking the cleanup, is it now? Oh, you know what? Let's do the plan again. And then, oh, it actually did it again for me. Okay, cool. Yeah, it was just because of the syncing process. So, all right, let's apply this. Now, I just want to see my database back here. That's all I want. Not too much to ask for. Where's my database? Where's my database? Where's my database? Come on. Interesting. No database. Let's look at the manifest quickly. At this point, it might be just easier just to delete the network policy. Right, so it did not trigger the change, right? Oh boy. What I like to do in these cases is to use here the file name. I'm going to use alphanumeric file name that's randomly generated, so then I know it triggers the changes. Okay. All right. So if I look at this manifest here quickly. Yeah, still nothing. Okay. All right, let's do this. So the file name, it gets it from here, which is always the same. So if the file doesn't change, nothing changes. There's nothing to trigger changes here. Okay, so we're going to use we're going to generate the file name here. So then it will always. What the hell? Do I have a bracket here at the end? Okay. Without the bracket, so that should be enough. But I'm going to generate. Let's look at the Terraform alphanumeric or just a random password generator here. Yeah, let's do that. All right, let's put some comments here. So this is our network policy. Let's see, fix to be used with Helm post renderer. Renderer. And then we also want to have now where is that resource? I want to no, I want to change the file name with okay, so I'm going to use the random resource here. Generate file name. We don't have to do the whole file name, just partial at the end. So it changes slightly every time. So it's just a quick trick to trigger to tell Terraform that there's been a drift in Terraform state or change, and to apply it. So in this case, let's do resource. We are going to use the random come on cursor, random ID. All right, so let's call this file name suffix. Let's just give it at the end, a file name suffix, and we're just going to make it very short, bytes length, 4, just small, and then in here, what I'm going to put right here at the end, we're just going to go put the random ID file name suffix that okay. All right. Hold on. No, I don't want to use the results. Let's use the hex. Let's use hex. Okay. So if you look at the doc here, let's bring it to this side. Come on. Move over to this side. So if you look at the random ID resource, it has, so there's the bytes length, there's the hex here. So we want to use hex. Okay. So it just hexadecimal digits, right? So it just generates a little bit of a suffix there at the end, and it's going to be random each time. And we're good, right? Yeah, just like the server name here. Same idea, random server ID here. Now, do I want to use hex or something that is less hexy, more of a string? Yeah, let's put a hex at the end. We can always do random string. Why am I doing ID? Let's use random string. Yeah, let's use random string. Why will I use ID? So we can just add a random string at the end. Hold on. We want to escape some special characters here because some of the characters can break the file system in Linux. So I think it's just safer to use hex. Just get like 4 hex numbers, which are just a string. Yeah, let's use hex. Just less headaches. We don't have to deal with escaping special characters. I don't even know which one to escape right now. Top of my head, I want to look at it. So anyway, so let's do that. All right, off to the side you go. Back to Terraform. So, the idea here is to force changes to be detected whenever. So every time it's going to be applied, every time we do anything, it's going to apply this, which is fine. This is a safe change to do, to apply it each time. And we're also deleting, cleaning it up a bit before we do anything. Okay, so that should work. Okay. All right. Let's push this change. Create a pull request. All right. Where is my big bucket window? Big bucket. Yeah, we're good with that. Looks good. Yeah, we didn't clean up. Let's sync it with main. Oh, well, what? I have an extra bracket there. What? Where? Where is the issue? What? Where? Invalid function. Well, that's new. Moral of the story: clean up your gits, follow the process, follow the GitOps process, clean up. Don't just pile on top of your previous commits. Let's look at the file changes just in case here. Yeah, we're good now. And these are 3 commits. Yeah, so the merge, adding and the merge on top of that. Yeah. All right, next we're gonna have to clean this up. I feel like we should do some math today. I think like we should just go randomly on X and just pick up math questions and just answer them. That might be great. Great way to spend time. The dog is just sleeping out. Too cold for you, huh? You're not sleeping. I see you. You're not sleeping. Did I just wake you up? Oh boy, I'm sorry. What's up? You going for a walk? It's minus 12 and windy. We're not gonna go for a walk now. Oh. All right. All right. There's a database. It's back. Woohoo! We made it. All right. Let's have a look at the. Just since we're done with this process, just look at the results and. So, yeah, version 7 is out. Okay, let's look at the. What? You want to go for a walk? No, we can't go for a walk, man. It's too cold, man. I'm fragile. I freeze easily. Yeah, there's our separator here in the manifest. So we're good. All right, so that's all good. Let's clean this up a bit. so we don't have to pile up on more branches here on top of each other. That's actually an anti-pattern. Don't tell anybody. All right, and then we can delete. Oh boy, this got really messed up, didn't it? Anyways, so back at in our trunk, let's delete this branch. All right, we're good. Nice and clean. All right. All right, so that's good. Let's kill the stateful set and see if the network policy is causing headaches. So let's kill. What's up? Why are you staring at me like a weirdo, man? Just we're not. You're not going for a walk, man. We're not. All right, let's kill this pod. The expectation is that's going to restart without database issues, okay? And if it is, then we're done with this phase of deployment. Production ready system. Production makes things complicated. Makes the code look ugly, yucky. That's my ick. Production is the ick. We have to start new YouTube short channel with Tony and talk about our icks. My ick is production code. It's icky. And so let's see if it comes back to life or we have issues. Let's look at the logs here. So far, it's looking good. No database errors, nothing. And again, back to this weird output from Langflow, because they hate DevOps people for some reason. I don't even know what that column is. It's just strange, man. Like the rest of the output is fine, and it comes like it puts in a column. So that's how the Docker logs look. There we go. It started. Okay, so we're good. So we have a production-ready system, custom Langflow Helm chart. We customized the Postgres Bitnami Helm chart. We made it secure. Now what's left is to adjust the pod monitor network policy, because we do have a pod monitor here, which is on the, it's scraping the backend fast API server, Python code. So let's see how the pod monitor is doing. I'm suspecting it's crashing because we didn't open a port for it. So get pod monitors from all the. All right, so we have a few of them. We usually use service monitors, not pod monitors. In this case, I chose to add a pod monitor because they had a scraper there. So Kubert, Langflow, that's our namespace. Right, so let's just have a peek at that one here. Let's just dump the YAML here. Langflow IDE. All right, so it's been deployed and it's looking to talk to metrics endpoint. Okay. Now it's doing a good job. So what we can do is we can connect to a Prometheus instance and look at the targets that's scraping and see if this is a good target, right? So we can inspect it differently, but I like to go to the GUI, the Prometheus GUI. So we have Prometheus deployed, and well, let's go through Prometheus service. So we have it in an observability namespace. I think I call it Kubert observability. Let's get the namespaces. Right, Kubert observability. So that's where we have all the observability tools. So let's get all the pods there. Actually get the services because I don't care about the pods. Let's just go through the service. Oh, yeah, let's go to a service. Let's look at the SVCs. So let's do, I'm going to port forward to which one here? Prometheus operator, Prometheus Grafana. I want to have a peek at this one here, Prometheus. Here, let's go to 9090. Okay, so let's do that. So we're gonna go into do port forward. SVC, just do it at the end. So SVC slash slash the name. Where's the name? I want this one. And port and local port as well, 9090. Let's see if that makes sense. Sweet. Oh, why are you punking me? Okay, cursor. Right, let's open it up here. All right, so this is Prometheus, right? Let's have a look at the status here and look at the server's discovery first to see if it's discovering that pod monitor first. So we have many different things we're looking at here, many different targets. And we are looking one from Langflow namespace. Langflow here. So there it goes. So it did pick it up. I can see it's not doing much. So service discovery is working. So it did grab the right one. So the labels that we put on the pod monitor are picked up by Prometheus, and it picked it up. So now let's look at the targets. And in here, we can maybe collapse some of these things here. I'll look for pod monitor for Langflow, this one here. Right. So as expected, it's down. It's not connecting to it. I don't know what's getting 504. It should be more like, well, it is a timeout, I suppose, so it should be 504. Okay, so this is because we blocked that specific port, or we haven't opened it here too. So we need to open up ingress port in our backend stateful set to allow the scraper to talk to this port, okay? All right, so the question, should we do it in a chart as a default, or should we just do it here as a values YAML? So we can always come back, do it here. So we can update, add an extra ingress. Now, it is part of the Helm charts. The Helm chart should automatically add it for us, right? So I'd rather put this in a Helm chart so we don't forget it when we do it next time. So if you go to our Helm chart, go away, Gemini, go away, go away. All right, so when we define the ports in our in our template here, where's the port? The ports here. So we add the metrics, right? So we should have the metric right now enabled. So if you go back to the stateful set and we have a peek at the container, we should have multiple ports in here. Yeah, we do. So the ports are here, right? So we enable, added the extra port. It's port 9090. And the pod monitor knows how to scrape it based on the path that we provided, sure. But we now also need to add this to our network policy. Let's do that. And we'll release a new Helm chart. So the same way we're adding it here, let's add the network policy for the backend. Let's add it to here, ingress. So again, we can add it as an extra ingress, but I'd rather have it here because it belongs to the chart, right? So I think we can just do it here, just like this. Just end it. Okay, and then we can just put a port in here. And then port is, oh boy, the pod monitor works based on the port name, but the ingress or the network policy works on port number. So do we have the port number? I think yeah, we do. So it's metrics, pod monitor, port. That's what the port number is. Okay, and then the name. Where's the name? The name is taken from the service. Okay. So in here, what we're going to do is we're going to give it values dot backend dot metrics dot pod monitor dot port. Okay, just double check. Port is the number. Yes, port is the number. Okay, sweet. So when it's enabled, actually we have to look for both. Enable this, just because we might add a service monitor after, so I won't be able to disable this one. So the metrics might have more things here. So that's what we have two. So let's do both. Going back to our network policy, let's do end condition here. So end is it brackets around end? Oh no, where's my end conditions? I keep forgetting. Do we, for these Go templates that we have in Helm, do we, let me just add it here anyways. I'll figure out in a second. So values, so that's how you do end, one beside each other. Values, backend, metrics, that pod monitor, and this is going to be enabled. Let me just double check the syntax on these, the end condition, because I forget. We should have one here, should we? Yeah, okay, you don't have to, okay. It's weird, but whatever. So, okay, so that should do. So both have to be enabled, and then we add a port to our ingress, and the ingress will have additional port. All right, let's do this. So I'm gonna bump up the chart version here, since it's our chart, 13, lucky 13, right? Let's package this. Not so fast, let's package this. Come on, cursor, what's wrong? All right, we'll package this. Now let's push this to the repository, version 13. All right, now we need to bump it up in our deployment. Okay, so we don't have to add it here anymore. Let's remove some of the empty spaces here as well here. I don't know why I have so many empty spaces all over the place. I guess we need to put cleanup in our post hook, git hook, or commit hook. Anyway, so environments here, I'm just going to go and bump this. Oh, sorry, and prod bump this up to 13. And the rest should be okay because it's already enabled. So that's it. Okay, so let's follow our Git process here as well. So let's just create a branch. Okay, so clean up some empty spaces. But here we're just bumping up the chart version, which has the updated ingress network policy with the ingress updates. Let's push the right chart, push. There we go, push the right branch, I mean. Okay. Time for another pull request. Right, so I'm removing empty spaces and just upgrading the chart, okay. The dog is upset. Yeah, I'm talking about you, yeah. All right, where's my update? Come on, Atlantis, hurry up. Oh, there we go. All right. So the only thing that should happen right now is just the network policy should be updated. So that should be fairly quick. And it should allow for the scraping of metrics in the backend pod. It's taking longer than it should have. It's not refreshing it, is it? Oh, okay. It refreshed. Oh, just because I removed the empty spaces. Oh boy. All right. Lesson learned. Update your commit hooks to clean up empty spaces, which I usually have. For some reason, I have it on this project. All right, so we're good. So that's one right now. Let's look at Prometheus. Let's see if this resolves itself. Come on, Prometheus, you can. What's happening? What's happening? Port 9090. Yes. Let's verify. Let's look at the ingress. Where is my network policy? There we go, here. I don't see it. What happened? They are in the right place. What did I just do? Hold on a second. Let's look at the labels here. This should be version 13. It is version 13. So where's my port? Where's my port? Where is my port? Did I mess this up? Enable. Oh, with the D. Oh, the pain. The pain is real. With the freaking D. Freaking D. Yeah, it's enabled. All right, let's bump up the chart. We'll reset the numbers later. Oh, the pain. Time for cleanup. GitOps doesn't clean up itself, although after we deploy these agents, they will. All right, new quick branch, that branch, just to bump up the chart. All right, new version 14. Okay. Pull request time. Come on, Atlantis. All right, well, there should be no deployment now. Why are you deploying, man? I didn't change anything. Why are you deploying, bro? Why? There are no changes. All right, well, this is resolving itself. Let's look at the network policy if it's been updated. There we go. So it's been updated. Now let's port forward to, again, back into Prometheus. Let's see if that target is getting scraped right now. Let's refresh this. Still down. Give it a second. Give it a second. Still not finished loading or bootstrapping. Takes a while for it to bootstrap. There we go. So that's good. Let's see if this is good. It scrapes every 5 seconds, so it should let us know right away. Now we're going to double check this in a second if all the properties are correct, if there's any configuration issues. So right now the port 90 on this specific IP is good. So port 9090, and we know ingress has been updated. So port 9090 is good to go, except for the selectors. Oh, snap. Oh boy, you know what? I need to do this from a different from. So this is where the business rules for network policies are a bit strange to understand because they're encoded in the structure of the network policy in terms of. So if I grab this right now, I'm just going to create a graph viz diagram from this because it's nice to have it now. Commit the diagram. So let's do it here. All right, so let's just see if we can get a good diagram here going. So graph viz, let me start a new one here. I usually randomly just pick a website, a graph viz website to use. Okay, so let's see if you have a, okay. All right, let me see. I need to adjust this a bit just to explain. Okay, so, right. So the client pod needs to have this specific, label on it, set to true. And then, so the pod monitor doesn't have that label. Okay. And anyway, so we hear this egress here, so we don't care about that. But so we need to adjust the pod monitor labels to allow it to access as well on port 90. So as you can see, it's not just the ports, it has to be with this specific label, right? Okay. So let's adjust it. Let me see if I can change the diagram quickly to show. So what if Let's see if we can adjust the diagram a bit. Let's see if this is a better version of what we need. Right. So something like that. Okay. So to access the server, we just need this label and port 7860. And for monitor, we need that. Okay. So let's do that. So we should probably do this in the Helm chart. Let's bump this up. So I'm going to move this to the side. So I have the diagram here. Okay. Okay, where is my chart? Here. All right, so we're obviously going to bump up the chart version. And for network policy, we are going to make an adjustment here. So instead of putting it here, we'll do another one. So let's do from and ports. So this will be ports. And I can put this one here underneath this one. And from, let's have the labels of the pod monitor, which I have what I put in the monitor. We just have the standard labels here, and we have do I want to do that? I do want to restrict that port 90 only to the monitor, but do I need to fiddle with this a bit with the select? So the selector is fine. So we'll talk about these labels here, additional labels. So, let me add a label here just as a component. So on top of these labels here, the common labels, which we mix the Prometheus labels and with the common labels, I'm going to add one more label here. I'm just going to call it component backend monitor, pod monitor. Okay. And then I can use this label here as the label in my network policy just to kind of restrict access. So in here, I'll do a pod selector. It feels weird doing a pod selector on. No, it's not the pod selector. Hold on. This doesn't make sense. It's not the pod monitor that's doing the access. It's the scraper, right? So is it still on the screen? Where's my screen? Prometheus. Right, so these are the labels here. So it's scraping with these labels. Calls are coming in. Okay. So these are the labels. So there's actually more here. Obviously, we can expand here. What would be good label to add here? Now I can do without labels, but then it's not the best because we want to restrict a little bit more. Because if you just open that port, then anybody can access it. I know it's just metrics endpoint, but there could be bugs there. It's just another way for people to get in. Oh boy. So since the scraping is happening with the scraper is a daemon set that that sits on every node and scrapes different pods and then sends them to the Prometheus database. We should use the labels of that versus the labels of the pod monitor, which is just a custom resource. That would be the best way of doing it. So the simple thing is would be just not to add a selector. Let me see. What would be the best way of doing this? Yeah, we need to add the Prometheus, right? The Prometheus. So let's look at the Prometheus. So let's look at the Prometheus custom resource, and yeah, that'd be the best way. Okay, and then we can use the Prometheus custom resource to guide us in terms of which label to put there, and maybe we'll make it customizable since that is something that we grab from Prometheus deployments. So let's just look at the let's go here and grab the Prometheus deployment. Where's the Prometheus live? So there's a Prometheus and observability. So let's inspect it and look at the labels that we have there. And then we'll update it. So that's the name. And then just dump the YAML and just look at the selectors there that we configure YAML. All right, so there we go. So this is our Prometheus deployment. Okay, so where are the labels, right? So pod monitor selector here. So this is just to select the monitor. So I think we should add the Prometheus label as the pod selector. Right. So we have different match labels here, different selectors for different Prometheus assets, but they're only for Prometheus. They're not to configure the network policy. So the network policy should be configured with the label on the Prometheus. Now, is it Prometheus or the scraper? Which one? Will scraper do the work, right? So Prometheus is just there giving access to. It's the engine, but it actually doesn't do the work. So you know what? I'll probably make this configurable. Okay, so the Helm chart doesn't need to be aware of these details. So that's the first thing. And then we add these details in our deployment, right? So going back to Helm chart, let's have a selector to configure. So I'm going to make this configurable. So make this a template. So match label here. Match labels. Okay. And we can include here a variable. let's add a variable here. We'll add a new variable. So let's make this pod monitor and just make this a value. So the idea here is to push this to deployment time because we don't know ahead of time what's going to be here, but provide an ability to make it configurable. Okay. So pod monitor, let's call this pod selector. So then we don't have to touch the chart. We can deploy the chart and we can fiddle this deployment time. So let's add this to the values YAML. Scrape down labels. Let's put on the labels here. So this is specifically for it's going to be parameter, backend, metrics. Let's call this additional labels. Okay. And we're going to make this an object. Okay. So you can provide a map. So you can provide multiple labels there. Okay. All right. So let's bump this up. So that's good for the chart. And then we can move this to deployment time. Okay, let's add some docs in here. So I'll update the README file with the new variable. Pod monitor is good. There's no changes here, right? Yeah, except for that one here. Yeah, I don't need to add this anymore. So just remove this. Okay. Yeah, let's get rid of this. Okay, we don't need this. Okay. All right, so that's good. Yeah. So the only thing we're doing here is providing a new variable here so we can configure a deployment time. So we can configure the selector that goes with the port. Now let's change the if statements. The if statement is going to be around the whole thing here. Comes as a whole. So this is strictly for monitoring. Okay. All right, that's good. Let's package this. Let's push this chart. All right, let's put this to the side. So now we need to figure out what selector we're going to add here. So this is going to be version 16. And we have now a new variable, which is we call the pod selector. We can put this in main here. So this one is in backend. Metrics. Pod monitor. Pod selector, okay. And values. So we need to figure out what value to give it. All right, now since this is an object, we're going to add it here. And then the value here. So we're going to add the key value pair. So the key is going to go here and value is going to go here, okay? All right, so what do we add here? Now, I want to start with the Prometheus labels, which is what? Where's the Prometheus labels? So if we look at the Prometheus resource we just looked at here, it has this. But we also have Yes. So you know what? Let's grab the scrapers and let's look at the scrapers because they do actual work. What's going on here? Come on, Google, work with me here. All right, so let's go to the namespace for observability and just have a peek at the scrapers that we deployed, and then just grab the label. Okay, so we have right. So these are the node scrapers here, right? So these are the ones that actually do the actual work, not Prometheus. So let's look at these pods. So I want these pods to. Let's actually look at the logs here. Let's see if they're trying to talk to that endpoint and getting stopped by the network policy. Okay, no logs. Let's look at all of them at the same time. Okay. Right. So I do want to see if there's an error here for Langflow. Let me just see if there's a. Let's search for Langflow. No. Is this case sensitive or case insensitive? Tell me, Google. All right. So I'm just double check the Prometheus logs just in case to see if that one is doing the Prometheus. We want to look at Prometheus stock. No, where's my Prometheus? Prometheus. Stock operator? No, I don't look at the operator. I want to look at the deployed Prometheus. Yeah, it's this one here. Well, okay. It's a stateful set. All right. So let's look at the logs. I'm trying to figure out what would be the best pod selector to add on the network policy to allow scraping of the metrics here. Okay, so we have some errors here. Beautiful. All right. So the discovery is happening, and here's the error. Let's look at the error message. Right. So it's the Prometheus instance that's committing the error here. So I would allow it to do the scraping. All right, I'm just gonna do this one for now. to because that one is used pretty much with every part of Prometheus. So that's a safe bet. So if you come back here, just to deploy it and have something to compare against. So if I just dump it here, so we're going to say that this part here is going to be the key, which is going to have to escape that, and the value is going to be Prometheus, okay? Right, so this is what we have. Now, you cannot have slashes here in the name, so we have to escape them. So usually escape it with a double slash, as I recall. Is that correct? Where's my the doc here? So this will be in Helm release here. If you go to Helm provider, let's look at the documentation. Let's look at the version we're using, not the latest version. Helm resource, or Helm release, and I believe they have an example here. Yeah, they do. Okay, so it's okay. I literally have the same example as I'm okay. Prometheus annotations. So it goes slash the other way. Okay, hold on. So that's for the dot and nothing for the forward slash. Okay, well, it's good then. I thought it was the reverse. Okay, so we just gotta skip the dot. All right, so it doesn't get confused. So there's no dots here. Just for no, that's the dot we need. So that's good. Hold on. Is that valid JSON key with the slashes like that? I suppose it is. They don't escape it in the Helm documentation, which is a bit strange to have a forward slash in the name like that. Okay. Well, doesn't matter. If it works, it works. Okay, so let's add this. What's the changes? Did I do any changes here? We'll see what the change is. So change here, 16. Cool. Let's just close. This is safe. Okay. I'm just going to kill some of these things here so we don't get confused. This, I want to keep this little, you know what? I'll just put it in my test folder here on the scripts. So I'm just going to call this client, Ubuntu client. Ubuntu client test.sh. All right, I'm just going to dump this here. All right, sweet. Kill this. Just going to make this a runnable script. So whenever I want to run something, I'll just execute the script. So this is a client that doesn't have anything in it versus like the client we use here for testing network policies, which came with the network utilities. This one is just Ubuntu, and we just install the stuff we want to install. So yeah, that's good. Okay, so used for testing. All right. All right, cool. I'm happy with this. Save this. Go away. All right, let's look at the changes. So we bumped up the chart. The chart now requires a new property for the pod selector, which is going to be Prometheus. Okay, cool. All right, let's deploy this and see what happens. And again, you know what? Let's clean this up before we do more damage. Check out main. Can we? Oh, it's gonna. No, it's gonna complain. Okay. All right. We don't care. All right, I'll push the same branch and we reuse the branch and. Just space removal. Okay, we'll keep this. All right. Okay, let's do pull request quickly. And we're gonna have to do some syncs with the main. Okay, so that's good. Yeah, removing the stupid space over there and adding the script. Okay. Yeah, we got to sync with main. There we go. So the only thing that should happen now is we should get a new network policy, and it might work, might not work, but at least that's the only change we're expecting. All right, it's refreshing the pods, although it shouldn't, but we had a change in the values YAML with the space cleanup. All right, let's see if the network policy has been updated now. Not yet. That is still the old one. Hold on for a second. Did we push this? Yeah, we did push the 16 to... No, we just packaged it. Damn it. Damn it. I didn't push it. Like, no, wait. It's push chart. Make push here. No, it's good. Otherwise you complain. What am I doing? It's fine. Confusing myself here. Okay, now why isn't this being updated? What's the problem here? Did it crash? No, that deployed correctly. What about here? Oh, the network policy has a problem. What's the problem? Right, okay. So let's have a look at it in the terminal just to see. Let's just grab all of those. And we're going to look at this one here, this manifest. Look at the failed one. Okay, so what is happening here? Where is the failure? So we do have the front end. That one's good. Where's the back end network policy here? Right. So maybe I was correct. The forward slash didn't work as expected here, or I didn't put YAML on my freaking Helm charts. Right. So you can see that it did add it. So that's good. But it created a map. That shouldn't be a map. That should be a key value pair here. Okay. So let's fix this. Yeah, that's a bug. All right, let me see on my Helm chart if I made a boo-boo there. So since this is a dictionary, we usually use, I usually use these templates here to render stuff. So you can see here, here match labels here, and we get it from common labels. So Bitnami has already a lot of support in the common chart, the library chart, to actually deal with this. So let's do this. So we'll do the same thing here. The match labels here, and we're going to pass in the variable here, which is this variable. Actually, do we don't have to pass in the custom labels? We can just do it with without it. Yeah, just pass in value. So yeah, I'll just grab this one here. This is a better version. We just have to be mindful of the how many indents we have to have here. So render, and then we're going to put the value here and put common annotations. This is similar to, what am I doing? Not here. 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 Okay. And we're going to grab this, put this in here. So if you look at the this example here, common annotations. So if I look at this in the values YAML, you can see it's just that, right? It's just annotations. So it allows you to define the key value pair. So you're doing the same thing for a selector, same idea. It's nothing different here. Okay. So we can reuse the same template renderer. We can pass in dictionary here and pass in the value. So that's what we're doing here. So then we don't have to deal with us parsing it. Now, the only thing you have to think about is the indent here. So you have to provide the right indent, otherwise it's going to cause a problem. So, usually you can just count from here, from this side here, what's to have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So 12. So we're going to give it 14. Okay, so we're going to move 2 over. Okay, so it's going to be indent of 14. Okay. So this will render the pod selector for us correctly based on the value that we pass in here. Okay. Yeah. Now we can test this right now before we do anything. So we can just have a look at the Helm template. We can generate it. And snap. So we can do make template. And I'm just going to run the whole thing. Now, right, so it doesn't have the pod monitor, I'm assuming, because, sorry, the network policy, because we didn't enable it. So let's see, there's network policy. No, okay. So what I'm going to do is I'm just going to go to the values and just trigger the network policy for the backend first, and then also trigger, so I'm going to enable this, true. I'm going to set this to true, just to simulate it and test it. And then I'm just going to add here my selector testing equals happy. And then we need to enable the network policy. So network policy should be set to true as well. There we go, true. And now we can generate the template again and see if it's good. So now we should make this a bit higher. So there's network policy. And this is how it looks, right? It's beautiful. So it works. And we can see how it's going to look the final result, okay? All right, so that's good. So we did a quick smell test of how a template will be rendered. That's good. So just now go back and put back the default values and false suite. Okay, bump up the chart and deploy it. The chart version to 17 now. Let's package it and push it. Hello? All right, there we go. Okay, now we can go back to our deployment and change the version of the chart. So we'll pull the new version from the repository during deployment. So we're going to bump this up to, where's the version? 17. All right, let's push this change to our double branching issue here. Let's pull this. And now push it. All right, so this at least should generate the correct syntax. And we should see these right away and when we apply it. There you go, finish planning stage. Now let's apply this. All right. Yeah, it's nice to have control of both the Helm chart and the deployment at the same time, so I can fiddle with both things at the same time. And let's see, why isn't this liking invalid value name? Right. Okay. That's more like it. Okay, so it's not liking the key value pair there. Let's have a look at it, how it looks in the manifest. So I'll just make this a bit bigger. Okay, so where's the networking? Scroll up, let's find the networking section of this huge manifest. Okay, so there's the front end, where's the back end? There's the back. Okay, so that's good, but not great. What is this case? A pod in front of it here. What? Let's look at the values. Sorry, the main where we use this. Right. Yeah, I don't want this like that. Okay. So, okay, so we copy pasted those copy paste boo boo here. So going back to the workloads, and looking at the Prometheus observability section, let's look at the Prometheus scrapers again. node scrapers, and let's look at any of the pods. Just grab the label. Right. So we wanted to grab something that is common to all of these things here. All of them do add this release Prometheus stack. Now we use this to attach pod monitors and service monitors. So I don't want to use that. I want to use something common. So I'll probably use this one here. Okay, just like that. Instance name. You know what? Let me use this because this is a label I created specifically to be able to use with outside of the Prometheus deployment, and I think it's added to every pod that is part of the Prometheus stack deployment. So you know what? I'm going to use this now. I don't need to get it from here. So let's go back. So this is the one I want to add right now. Now we can grab this from the observability Terraform state, which we already have it here. So using the same. So I'll use this for both selecting the pod monitor, and I'm going to put it here and just grab the value here. Okay. So it should add this specific selector. And the reason this is bad is because this is something that is configured in a different Terraform project, and it's maintained there, and it just provided to us as an output, so we can just use it. So it seems like a better option. Let's just see if it will select the right container for us, the scrapers. Okay, let's see. Where's the pull request here? All right, let's apply it. All right, so it finished applying it. Let's see what we have right now in the network policy. All right, so here are the changes from Prometheus enable. Oh, see, that's not the right, not, okay. So the chart is working. We might want to fiddle with the label here, use a different output here. Because this is when we're enabling resources, right? So yeah, this is not the label I want here. Anyways, but the rest is fine. So we can, let's see if we can see if that label did anything just for fun. It shouldn't, but let's just see if we got lucky here. Right. All right. So let's just add a different label here. Yeah, so I'm going to add the label I was going to add originally. Now just clean up the Git here because it's just getting really, really messy. So we do want to follow strict trunk-based development here for CI/CD processes. not some Git flow. We don't have long lived branches. Let's just clean up this branch here. Just delete this. Yeah, delete the original. From the branch as well, from the, not just the local one. Yeah, you be gone. All right, we don't care if it's not there. It doesn't matter. All right, so cool. So now let's just create a new branch so that we can provide a better label or selector. Now we just have to figure out which selector is the best one there. All right, sweet. So going back here. Right, so this specific selector here is only to select to be used with the monitor, pod monitors, and all service monitors. So you can see it says Kubernetes resource enabled. So we don't want that. We want the one that's actually on the Prometheus, not on the monitors. So let me have a peek if we actually exported one from the observability repo that we can use. So just create a new window. Let's have a look at the observability project quickly and see what we have there, something that we can use. So for Prometheus deployment, let's have a look at the outputs. Okay, so this is the one we used. That's not a good one. Yeah, we didn't expose a label for us to use as a selector because there was never a need. So you know what? I'm just going to hard code one for now, and then I probably will go back and change the Terraform for Prometheus deployment to have a nice label. Now here, what I'm going to do is just use the regular app instance, Kubernetes app instance equals to Prometheus stack. Is it here? Can you just grab it from here? No, we don't have one here. Okay, so just go back here. Let's go into observability namespace. Where's my observability namespace? You hiding? There we go. And I'm just going to grab something from our pod, a label here that's common to all of them, and use that. So like I was trying to do before. So yeah, so that's the one I'm going to grab. Maybe I should, no, let's just do one for now. That should be enough to grab any pod or any pods that are related to Prometheus. Now it would be nice to kind of grab the version as well, the Helm release version. But I'll add that once we'll make this something as an output from the Terraform state deployment and observability, so we can dynamically inject it. For now, I'm just going to use this. So this is the one I'll grab. All right, so this is what we want, right? So Prometheus is going here at the bottom. That's going to be the value. And the key here is going to be this section. Now, this is where the dots are. So let's remove the dots. Let's escape them. So as I recall, it's double slashes here, like that. That should work, okay? All right, let's see if this solves the problem. All right, let's push this. What happened here? What happened? Okay. Pull request time. The best time of all the times. Let's apply it. All right. So the only change we're expecting is just a label on the network policy. And where's the label? Yeah, so here's a label. Okay, good. Okay, now let's port forward to Prometheus and see if the scraper is allowed to scrape that endpoint right now. Oh, the port forward is all right. Let's give it a second. We have few unhealthy ones, but we really care about this one here only. We'll probably debug these ones later. But right now we care about this one here. Yeah, still not scraping. Okay. All right. Let's update the label. So looking at the network policy here, it has to come from this specific one. Okay. So let's see what we get. Let's just give maybe a few more seconds just to see if right. So yeah, it's not picking it up. Okay. So you know what? Let's just see what comes up with that selector. So let's just query the specific pods in that namespace. Oh wait, hold on. I didn't put a namespace there. That's why. What am I doing? So look at the name. Okay, so this should be. Oh boy. So the selector here is there has to be namespace specific, right? So this they need a namespace selector because otherwise it just looks for pods within the specific namespace. So, but anyway, so let's get the pods. Yeah, and double check get pods from observability, right? So now we'll just add a filter here to label. So that label that we have, I think we need to put quotes around this. Equal, that should be equal. What am I doing? This should be equal, not colon here. Okay, so it grabs the Prometheus for us, right? So the only thing that's missing here is the namespace. And let me look at the Helm chart. Where's the Helm chart? So we have to allow, not this, where's my Helm chart? Where is the chart? Here. Okay, so in the network policy, we need to be able to allow namespace selector as well here. Yeah, here, this has to be a namespace. We can't assume that we're deploying the Helm chart in the same space where we have, when we have the observability stuff, right? So this has to be a namespace selector. Let's add this one here. So let me just grab the one I just did for, I'll just type that in. Langflow here. So we have one here in values. So let's grab this one here. Yeah, just like that. And remove this. Okay. And right. So we should also make this configurable as well. So let's add a new variable. Just like that. And we're going to call this pod selector and then namespace. Okay. So that's going to give us full configurability on where this is coming from, where the pods are. Let's add this to our values YAML. Namespace. All right. Okay. Let's bump up the chart again to version 18. All right. Let's have a peek at our merge request. So that's good. So let's clean this up so we don't get into trouble with our Git process here. Okay, delete the branch. Create a new dev branch. All right. So first, bump up the chart. It's 18. Now we have a new property here to add. So we'll do it in Terraform. We'll add it here. So set. And in this case, we're going to provide the namespace of the observability. So what's the best way of doing this? Yeah, let's do it like this. Metadata name. So I'm just going to put that here. Let's escape this. This as well. Okay. And just put a value here. Now for the value, we already have the observability namespace. So I'm just going to grab it from our observability Git project, because we usually just define it when we deploy it. So we always make it dynamic. So just grab any main here. So there should be, yeah, so here at the top, just grab this. It's just coming from the GKE state that we have where we manage the namespaces. So I'll just put this at the top here. So this is going to be your observability namespace. Just observability namespace, okay? And then we can inject that into here. Local observability namespace. Okay, so now this should give us better selector to select stuff from the namespace, observability namespace, and then grab the Prometheus pod. Okay. So I'm not saying that's the right pod yet, but at least we're in the in the right namespace. And then we'll see if we need to change it to maybe the node selector versus the actual Prometheus pod. All right. So that's good. Yeah. Sounds like it's time for a pull request. All right, just double check Kubernetes, IO, metadata, name. Okay, cool. And this is app. All right, let's see if this will improve the outcomes. Wow, this is taking a while. Is it refreshing the pod? It is refreshing the pod. Now, looking at these initial limits that we gave to here, they might be too high. We're going to have to go and customize this, but we'll let it run for a while, and we'll have a peek at Prometheus and decide then. So right now, I mean, it's not doing much, right? So it's not using much of a CPU. Memory is already quite high. It's to the requested. It's not to the limit. We gave it 2 gigs. So it is. So the memory is looking a bit suspicious, but the CPU is not being used at all because obviously nobody's using the application. We're just deploying it right now. All right, so that's done. You never want to prematurely optimize. You want to let it run, profile, and then see what happens. All right, so let's see if the network policy has changed. That is interesting because I made a mistake. All right, so it's actually grabbing all the namespace, which is good. But this should be namespace. Okay, holy crap, man! I think I have to finish it because my brain is just dying here. Yeah. So where's the actual correct name that I should be here? Pod namespace, right? So this should be here like this namespace. All right. In the meantime, let's see if before I update this, let's see if you can see if Prometheus is scraping it or not. Okay, so still not scraping it. So I'll add the labels for the scraper, not the Prometheus. So I think that's the one that should be there because it's actually doing the actual work. So yeah, let's just grab the scraper labels. So let's see. So node scraper or node exporter here. So let's see. So on the pod, because we need to grab these pods, 3 pods. Let's see what labels we can use here just to make them unique. Not at the top. Let's look at the here pod template. Where are you? Spec template. Where's my template? Pod template. Oh, this is already in the pod. Okay. So anyways, we can get these labels here. All right. So what if I just do this? Name Prometheus node exporter. So I'll do that. First of all, let's can deal with you know what? I don't care about these changes. Just I need to clean this up. Come on. Oh, source tree quit. Okay, we just crashed our Git tool. That's not nice. Why you be crashing? Oh, came back to life. Okay. Came back aggressively. Too aggressive for me. I'm fragile. All right, so I'm just gonna reset this so I can clean this up and check out main. Delete this branch. Let's create a new dev branch. Gotta be consistent. Gotta follow a process, right? It's all about the process. Gotta follow the process. All right, so I just fixed this up. So first of all, the namespace selector is incorrect because it has to be namespace in the name. Okay, and the second thing is I'm saying that we can use the node exporter as the name here, not Prometheus. Okay, so this will allow the exporter to kind of sneak into the container and do something. which we want. And I think that's the right way of doing it. If not, well, we can always test this with a client and go through a process of figuring out from first principles which actual the containers require, but that just takes time. It's better just to fumble around and find your way in the dark, right? All right, let's do a pull request. Okay. All right, let's see the changes. See if they made any difference. If not, we're still going to have to finish here. Network policy. Let's see. Yeah, has the right namespace now. And it's looking at the node exporters right now. So you know what? Let me actually update my. Where's my? Did I get pods here from? Yeah, okay. Should grab these 3 pods. Sweet. All right, let's go into Prometheus and see if anything changed. Come on, Prometheus. Don't be mad. All right, looks like that's the incorrect pod that we're actually selecting. Okay, so we'll probably end it here now. Not probably, definitely. Time to walk the dog in minus 12. Doesn't look good outside. But the bladder's going to explode. Right, Coco? Oh, she's sleeping again. Okay. So we're going to do this from first principles. Basically, get a client running, use some network utilities, TCP dumps, stuff like that. So we'll figure out what's happening here, where's the request coming, where is it not going, things like that. Just do proper debugging, just so we don't have to guess. We can pinpoint exactly what needs access to the specific port. And let's look at the IP address quickly. So this is 18.164, and what's the IP address of this pod here? Yeah, so it is the right pod. So it's hitting this specific IP address, but it's not, able to access the port. So it's actually hitting the same, the port here. All right. So it is making the request. The question is, what is making the request? I was assuming is the node exporters that are making the request because they're exporting data. So that would make sense to me to actually give them access based on the selector, pod selector. I guess I was wrong. So instead of guessing, we'll just kick off a client, use some network utilities just to quickly ping few things around, maybe do some curls around, see if we can curl that specific endpoint, same as Prometheus. And then we'll know, because really we just have to curl this endpoint and pretend to be Prometheus from our client to see if it works. So we'll do a debugging session later. Right now, it's time to go outside and try not to freeze to death. That's the challenge for the next half an hour. Oh, I can see the wind blowing. Oh boy. All right. We'll end it here. We're almost there. One more tiny bug to fix, and